Hello, I'm the multiplicative Mr. Daycock, and today I'm going to be teaching you about the quotient rule for differentiation. So what is the quotient rule and how does it work? Well, so far we've learnt about the chain rule, which is if y equals f of g of x, then y dash is equal to g dash of x multiplied by f dash of g of x. And this is the quotient, this is the product, the chain rule written in terms of functions rather than variables, but it is in fact exactly the same thing as dy by du multiplied by du by dx. But actually in a different order, it's this one is g dash and this one is dy by du. If you're not sure about that, you may want to pause the video to take a couple of minutes to think that through and see why that makes sense. Maybe try an example to see if you can get it to work. But anyway, that is our chain rule. Now, we also have what if y equals uv, our product rule, where u and v are both functions of x, then y dash is equal to u dash v plus v dash u. Today, what we're going to be dealing with is the quotient rule. And the quotient rule is exactly the same as these two rules. We're dealing with function y equals u over v, where u and v are functions of x, and we want to find y dash or dy by dx. Okay, the way we're going to do that is to use both the product rule and the chain rule here. So first of all, we want to rewrite this as a product. So we're going to write it as y is equal to u multiplied by 1 over v, and therefore y is equal to u multiplied by v to the minus 1. And now, to make this work, to make this make sense, I'm going to use capital U and capital V as my two functions for the chain rule. So I'm going to write this as capital U is equal to lowercase u. Seems a little bit redundant, but it's going to be helpful. And capital V is equal to v to the minus 1, and this is less redundant at this point. And now, I need to work out what v and u dash are. U dash is really easily because capital U differentiated with respect to x is the same as u differentiated with respect to x because they are the same. But capital V differentiated with respect to x is not going to be the same. We need to think of this in terms of dv by dx, and this is where the chain rule comes into play. That's going to be dv by dv multiplied by dv by dx. Now dv by dx is easy, that's just v dash, that's the definition of v dash. But differentiating dv by dv, well, that's also easy because it's just this, and it's just the power rule. So we're going to subtract 1 from the power and multiply by the original power, so v dash, or specifically dv by dv. Let's write that because we're not really dealing with dv dash because v dash is with respect to x. So dv by dv is going to be equal to minus v to the power of negative 2. And so that is minus v to the negative 2. And of course these are being multiplied because that's our chain rule. So dv by dx is precisely that, negative v to the minus 2 multiplied by v dash. And now we can just use our product rule. It's this times this plus this times this. So we now have that y dash is equal to, or in fact the very specific thing we're looking for, dy by dx, is u, let's do this in green to make sure it matches up with our colours, u multiplied by negative v to the minus 2 times by v dash, and that is the green arrows there, plus, because we're just using the product rule here, v to the minus 1 multiplied by u dash. Which looks really nice, apart from a few details. We've got this negative here, that's a bit nasty. Got negative there, which is a little bit nasty. We don't really want to deal with that, or at least we want to put it somewhere else, and we want to kind of simplify everything. So let's write this in a simpler form. Y is equal to negative uv to the minus 2 v dash plus v to the minus 1 u dash. And now we were dealing with a quotient originally, so we probably want to turn those negative powers into fractions. So we've got y dash, let's not forget the dash, is equal to minus u v dash over v to the minus 2 plus v to the minus 1 u dash over, apologies there, u dash over v. And that's not minus 2, that's just power of 2 at this point, because we used up the negative when we wrote it as a fraction. Okay, now at this point, what we're going to want to do is add those fractions. We've got two fractions, we want to add them, and so we're going to need to multiply this fraction by v to get the common denominator. And so we're looking at y dash is equal to minus u v dash over v squared plus v u dash over v squared, which is, I'm going to switch it round so the negative comes afterwards, v u dash minus u v dash all over v squared. And this here is the quotient rule. Okay, now let's use that quotient rule in a problem. So here's a problem. Find dy by dx when y is equal to 6 sine x over 4x to the 5 plus e to the power of 2x. And so in this case, we've got u is equal to 6 sine x, and we have v is equal to 4x to the 5 plus e to the 2x. Okay, now we just need to remember our quotient rule. So our quotient rule is dy by dx, or y dash equals u dash v minus u v dash all over v squared. And we just need to plug in those values. So we're going to get u is equal to 6 sine of x. So u dash is the derivative of that, which is just going to be 6 cosine of x. Nice and easy. V is equal to 4x to the 5 plus e to the 2x. And so v dash is just the derivative of that, which is going to be 20, differentiating the power, x to the power of 4, plus, differentiating e to the 2x is 2e to the 2x. And now we just plug all of that into our chain rule, into our quotient rule. Substitute it all in, and we get y dash is equal to 6 cosine of x times by 4x to the 5 plus e to the 2x minus 6 sine of x multiplied by 20x to the 4 plus 2e to the 2x all over 4x to the 5 plus e to the 2x squared. Now, in terms of simplification, there's a little bit we can do here, gathering like-ish terms. I'm going to write this as, I'll expand out the top. The denominator we don't want to expand out, that's not going to get nice. So we're just going to leave that as 4x to the 5 plus e to the 2x squared. If we expand the numerator, we're going to get 6 cosine of x multiplied by 4x to the 5. Well, that's going to give us 24 cosine of x multiplied by x to the power of 5 plus 6 cosine of x multiplied by e to the 2x minus 6 times 20 is 120, 120 sine of x, x to the 4, and we're multiplying a negative here, so minus 12 sine of x times by e to the 2x, and that's still all over 4x to the 5 plus e to the 2x squared. Now I said this was getting nicer, so far it's not. But now we can find our common factors of e to the 2x and x to the power of 4. So here, for the x to the power of 4, we have a common factor of 24. So we're going to get 24 x to the 4 multiplied by x cosine x minus 5 sine of x. And that's from this term here and this term here, factoring out 24x to the 4. And then we're going to add on, well, we're going to do these terms now. Yeah, make it clear that that's the green term. So we're going to get from that 6 cosine x e to the 2x. Well, the common factor we can factor out here is 6 e to the 2x. So we're going to take out 6 e to the 2x, and we're going to be left with cosine of x minus 2 sine of x. And that is our two blue terms. And this is slightly nicer because we've gathered our sines and cosines together. And so it looks a little bit nicer, and our non-sine and cosine terms are factored out entirely. And that's still all divided by 4x to the 5 plus e to the 2x squared, which unfortunately is not going to simplify. Okay, there you go. That's the chain rule with a nice example. And thank you for watching, and we'll see you in the next video to learn a little bit more about differentiation.